This is chapter 10. The title is Linear Regression. Today we talk about the homework examples. Here is chapter 10 formulas. The first one is the linear correlation coefficient, R formula. Second one is a t-test for the correlation coefficient R. Use T. The third one is regression line equation. Y hat equal B0 plus B1x. B0 formula. B1 formula. B0 is a y-intercept. B1 is a slope, and this is a slope-intercept form for the line, linear regression line. And the next one is the standard error of estimate for regression. Standard is a standard error of estimate, like a standard deviation. For the regression. First question, example. The two variables in a scatter plot are called A, independent variable and the dependent variable, B, relative frequency and relative proportion, C, spread and the pattern, D, lines and points. Answer is A. The two variables are in the scatter plot. This one we call scatter plot. Two variables, X variable and the Y variable. The two variables. One we call X variable, we call independent variable. Y variable is called dependent variable. So the two variables in the scatter plot, this is scatter plot, are called independent variable and the dependent variable. Second question, Daniel Weissman, a scientist for Grass Chance Corporation, wants to determine if the flow rate of a particular material changes with different changes in temperature. And this is a flow rate as an independent variable, and the temperature on Y variable. The data is plotted in the figure below. A, ask you, what type of relationship exists between the flow rate and the change in temperature? A is a negative relationship, B is a positive relationship, or C is there's no relationship. D is a curvilinear relationship. Which one? Let's talk about relationship. Here is a type of relationship. The first one, this scatter plot. When X go increased, then Y go increased. So the line is rise up to the right. Slope is a positive. If you draw a best fitting line, linear regression line, best fitting line is rise up to the right. Slope is positive. This kind we call positive. The two XY is a positive linear relationship. The second one, scatter plot like this. When x go increased, then the y's go decreased. If you draw a best fitting line, linear regression line, the line is fold down to the right. Slope, it's a negative. This kind we call negative linear relationship. The third one is the best fitting line is a curve, like a parabola, open downward, a curve. And such kind of relation is called curvilinear relationship. The fourth kind, the scatter plot like this. It's hard to get a best fitting line, like A or B or C. So such kind of scatter plot is a no relationship. And the independent and the dependent variable can be plotted on a graph called a scatter plot. The independent variable x is a plot on the horizontal axis. The dependent variable y is a plot on the vertical axis, y-axis. Scatter plot is a graph of the ordered pair, xy, ordered pair of numbers consisting of independent variable x and the dependent variable y. So let's look at this question. Question 2. And scatter plot like this. It's hard to get a best fitting line. So this answer is C. There is no relationship. Question 3. Construct a scatter plot for the data obtained in a study on the number of absence and the final grades of seven randomly select students A, B, C, D, E, F, G, total 7 students randomly selected from the statistics class. The data are shown here. Number of absence for student A is 6 times absence. The final grade is 82. Y is 82, 82%. Student B, absence 2 times. The final grade is 86. Y is 86. The student C, number of absence X is 15 times. The final grade Y is 43, and etc. G, student G, absent 8 times. The final grade Y is 78. And draw a scatter plot for this data. Solution. First of all, draw and label the X and Y axis. X-axis is the horizontal axis. Label means label this point is 0, then 2, and then 4, then 6, then 8. Those are labeled. And give the name, number of absence. That's a label. And draw the y-axis and label the number 10, 20, 30, and until 100, and give the name. It's a final grade. Give the title of this graph, scatter plot, is absence and the final grades. Plot each point on the graph. Like if absence 6, so find out 6. The x is 6, y is 82. So 6, 80, 82. So it's this point. X is 6. Y is 82. 6 and 82. So this intersection point is here. So this is student A. Student B, 286. 2. So from X is 2. Go up to 86. 86. Between 80 and 90. More than 85. 86. So this point, 286. Student C, 1543. So X is 15. 15 here. Go up to 43. Y is 40 between 50. 45 is middle. 43 is here. 43 and X is 15. Intersection here. So plot those 7 points. That's what we call scatter plot. Step 3, determine the type of relationship, if any, that exists. So you look at like this scatter plot. It's look like you can draw a best fitting line. So, and fold down to the right. When X increase, go larger and larger. Then Y, the degree decreased. Y decreased. The fold down to the right, slope is negative. So this, it looks as if a negative linear relationship exists between the number of students absent and the final grade of students, which is the more absence, the lower grade. The next one, linear correlation coefficient. R computed from the sample data measures the strengths. So R, linear coefficient correlation, R is computed from the sample data. R measures the strength and the direction of the linear relationship between two quantitative variables. R value is between -1 and 1. And R answer is rounded to 3 decimal places. If R equals 0, no linear relationship. No linear relationship. R, if very close to -1, closer to -1, is a strong negative linear relationship. If R closer to +1, is a strong positive linear relationship. Then question 4. Compute the value of the linear correlation coefficient R for the data obtained in the study of the number of absence and the final grade of 7 students in statistics class given in question 3. Solution. First step, make a table. Step 2, we'll find out the value for xy, x squared, y squared, and place this value in the corresponding column of the table. Because R formula, the R formula is this one. This is R equal n times summation xy, product of xy. So we need to figure out summation of x times y. Summation of x, so we need to figure out summation x. Summation of y, we need to find out summation y. over square root of n summation x squared. So we need summation of x squared and the summation of x squared times n times summation y squared. So we need to figure out summation y squared and plug in this r formula. Then we can figure out r. R is linear correlation coefficient. So we make a table and students A, B, C, D, E, F, G. Number of absence, those numbers are given in question 3. And the final grade Y is given in question 3. Those are given in question 3. Now we need to figure out the sum of x. So we add together 6, add 2, add 15, add 9, add 12, add 5, add 8. Get the sum x is 57. And we need to find out summation y. So add those y value, add together. 82, add 86, add 43, add 74, add 58, add 90, add 78. Use calculator. The sum is 511. Now here we need summation of xy. So x times y. 6 times 82 is 492. 2 times 86 is 172. 15 times 43 is 645. Keep going on. 8 times 78 is 624, and put on this xy column. Then you add together. 7 number add together. So summation of xy is 3,745. And we also need to figure out summation of x squared. So x squared, 6 squared, 36. 2 squared, 4. 15 squared, 225. Keep going on until a squared is 64. And add those 7 numbers together. Summation of x squared is 579. We also need to figure out summation of y squared. So y squared. Y is this column. Y column 82 squared. Use calculator. Get 6,724. 86 squared. Get 7,396. Keep going on until 78 squared. Get 6,084. And add those 7 numbers together. Get summation of y squared is 38,993. Then plug those numbers into linear correlation coefficient formula R. R equal n. N is 7. There's 7 students. Times summation of xy. So times summation of xy, 3,745. Minus summation of x is 57. Times summation of y is 511. Divided by square root of n is 7. Times summation of x squared is times 579. Minus summation of x squared. Summation of x is 57, so times 57 squared. Put it in the bracket. Times 7, n is 7. Summation of y squared. Y squared is 38,993 minus summation of y. Y is 511 squared. And use calculator. You will figure out this r is equal negative 0.944. Negative. So step 4. Conclusion. Make a conclusion. The linear correlation coefficient r is negative. So it's closer to negative 1. So there suggests a strong negative linear relationship between a student's final grade and the number of absence a student has. That is, the more absence a student has, the lower is the student's grade. Population correlation for R is for sample. Like a sample here, have 7 students is a sample. Randomly select 7 students. So that figure out that R represent the sample correlation coefficient. For population, we use this rho. Rho is the correlation computed by using all possible pairs of data xy taken from a population. So correlation for sample, linear correlation coefficient for the sample symbol is R. For population is rho. In hypothesis testing, one of the two is true. One is null hypothesis, rho equals 0. This H0, null hypothesis, means that there is no correlation between the x and the y variable in the population. Null hypothesis H1, if rho not equal 0, that is H1 means that there is a significant correlation between the variables in the populations. Question 5. Example. Test the significance of the correlation coefficient R found in question 4. We found out in question 4, R. It's a negative 0.944. Test that one. Using R equals 0.05. Test the significance of it. Alpha use 0.05. Use 5 steps. Step 1, state the hypothesis. Null hypothesis H0 is a rho. Population correlation coefficient rho equals 0. And H1, rho not equal 0. Step 2, find the critical values. Since alpha equals 0.05, degree of freedom is 7 minus 2. It's not minus 1. It's this time for correlation coefficient R. When we do testing, critical value, degree of freedom is n minus 2. There are 7 students. 7 minus 2 is 5, is degree of freedom. And the critical values obtained from use t-table. Use t-table because test value use t. So here we need use t-table. T-table you find out, use degree of freedom 5, 2 tail. Alpha is 0.05. Degree of freedom is 5. 2 tail. Alpha equals 0.05. So it's from here, and degree of freedom 5. 2.571. And 2 tail. So it's a positive, negative 2. Positive or negative 2.571. If you draw the curve, these two are critical values. To the right, alpha over 2. Alpha is 0.05 divided by 2. So this area is 0.025, and that's right tail. Left tail, the area also 0.025. If the test value falling in this we call critical region, you will reject H0, null hypothesis, support H1. If the test value falling between the two critical values, you will do not reject H0, fail to reject H0. So we are going to find out the test value, use formula T equal R times square root of n minus 2 over 1 minus R squared. So R is defined from previous question 4. R equal negative 0.944 because this question asks you test the significance for correlation coefficient R found in question 4. In question 4, we find out negative 0.944 944. So that is for R. So R plug in. Square root of n is 7 minus 2. 5 is degree of freedom over 1 minus R is a negative 0.944 parentheses square. And use calculator, you will figure out that T is a negative rounded. You can round it to 3 decimal digits. And negative 6.398. Here is a 5. So you round up. If 5 or more than 5, round up. Step 4. Make the decisions. Negative 6.398 is less than negative 2.571. So it's to the left. So it's to the left of critical values. And this number, test value, is falling in the rejection region, critical region, rejection region. So we'll reject null hypothesis. Reject null hypothesis. Null hypothesis. Step 5. So reject null hypothesis. Support H1. So there is a significant negative because R is negative. So you say negative relationship between the number of absent a student has and the student's grade. Question 6. 10 of points yielded a correlation coefficient R is 0.790. Test the significance of the correlation coefficients at alpha equals 0.01. So first of all, 5 steps. First step, state the hypothesis. Hypothesis is H0 is the rho equals 0. Is no relationship. And alternate hypothesis H1 is rho not equal 0. Rho is the population correlation coefficient. Rho is not equal 0, has a relationship. Then step 2. Step 2, we will find the critical values. And since it's a two-tail test, because H1 is not equal 0, not equal is a two-tail test. Degree of freedom is n minus 2. What is n? Question 6. Say 10 pairs, so n equal 10. 10 pairs points. 10 pairs point means xy. 10 points. Paired point. So it's n equal 10. So degree of freedom is n minus 2. 10 minus 2 is 8. And the critical values for alpha. Alpha, question asked you is 0.01 divided by 2. So each tail is 0.005. Right, left tail also 0.005. Critical value, we find out, is a two-tail test. Degree of freedom is 8. 0.001, two-tail. 0.001 here and go down. 3.355, positive and negative. Let me see, 0.001, 8. Two tails. It's 8 0.001. Here, it should be 3.355. I put it 2.306. 2 tail. So I put it's 2 tails. Number 8 should be 3.355. This should be 3.355. I make mistakes. So that's critical values. So it's 3.355, and this one's negative 3.355. Then find out the step 3. Compute the test value. The test value is plugged into the formula. T equal R. R is 0.79. It's a question given. Here say question R is 0.790. And square root of n is 10 minus 2. This is degree of freedom. Over 1 minus 0.79 square. And figure out is 3.744. Then compare it with the critical values. So compare this. And the 3.644 is greater than 3.355. Greater than. So it's falling in the critical region, rejection regions, to the right. So falling in the critical regions. So on this side is suppose H1, reject H0. So conclusion, reject H0. Since the test value is greater than 3.355. It's critical value. So falling into the critical regions. So step 5, since reject H0, suppose H1. So there is a significant positive because R is a positive, 0.79. So it's a positive relationship between the two variables. Then next question. Find the linear regression equation of the regression line for the data in question 4 and graph the line on the scatter plot. So solution. We are looking for this equation of the regression line is y hat equal b0 plus b1x. We need to figure out b0 and the b1. Use formula. b0 is a y-intercept. b0 formula is those. So we need summation of y. We need summation of y is 511 from question 4. And summation of x squared from question 4. Summation of x squared is 579. Plug it in. Minus summation of x is 57 from question 4. And summation of xy is 3745. Plug it in. Over n. N is 7 students times summation of x. We figure out from question 4 is 579 minus summation of x is 57 squared. Figure out b0 and round it to 3 decimal digits is 102.493. b1 is a y-intercept. b1 is a slope. b0 is y-intercept. b1 is a slope equal to summation n. N is 7. Summation of xy is 3745 minus summation of x is 57. Summation of y is 511 over n is 7. Summation of x squared 579 minus summation of x is 57 squared. Use calculate, figure out it's negative 3.622, rounded to 3 decimal digits, and plug into the equation of regression line is y hat equal b0 plus b1x. b0 is 102.493 plus negative, so become minus 3.622x. So this is the equation of regression line. That's the answer. Let's first find out. Second, graph this line on the scatter plot. This is a scatter plot get from question in the previous question 3. Scatter plot in question 3. And now we are going to plot this linear regression line, which is the best fitting line. Now, how to graph? We plot 2 points. Choose always to graph the regression line, select any 2 points for x and find the corresponding values for y. Find 2 value for x. Always select x values between the smallest x data value and the largest data value. For this case, x is between 2 and 15, because from question 3, this x is the number of students. Smallest one, x is 2 absence. Largest one is 15. So x is between 2 and 15. For this case, x is greater than equal to and less than or equal 15. For example, like I choose x equal to, plug in this regression equation. Y hat equal 102.493 minus 3.622 times by 2, and you got is 95.249. And plot this point. When absent is 2, x is 2, number of absent is 2, the grade is 95.249. So go up between 80 and 100. Here is 90, and from 90 to 100 we plug to 95.249. Plug these points. And the second points, I choose x equal 10. You can choose any points between 2 and 15. If I choose 10, then plug in x, get 102.493 minus 3.622 times by 10, get 66.273. So plot this point. X is 10. And y is 66.273. So between 60 and 80, and you got in the middle is 70. Here is 66. So when 10 and the 66 intersection this point, the 2 points, and use the ruler connect the 2 points. Connect the 2 points and draw the line, and that's a linear regression line, which is this one. And y slope is negative, so line is fall down to the right. Question 8. The equation of a regression line is y hat equal 4.6 plus 3.2x. What is the intercept of this line? Intercept 3.2 is the slope. Y-intercept is when x equals 0. Y hat equal 4.6. So 4.6 is y-intercept. So answer is C. 3.2 is the slope of the line. And question 9. Use the equation of regression line in question 7 to predict the grade of students who has 10 absence. So 10 absence. So substitute 10 for x in the equation y hat equal 102.493 minus 3.622x, substitute by 10. Figure out is 66.273. Then your answer, when a student has 10 absence, the student's grades will be approximately 66.273%. Question 10. What is the value of y hat when x equals 3 if the equation of regression line is y hat equal to 23.1 minus 3.8x? So you will do is y hat equal to 23.1 minus 3.8 x, use 3, plug in, and subtraction get 11.7. So answer is D. And the definition of coefficient of determination is R squared. Is explain variation. Explain variation is y hat predict y minus y bar mean of y squared. This explain variation over total variation is a summation of y. Y is observed value y minus y bar mean of y squared. So this is R squared. This equal R squared is we call coefficient of determination, which is a correlation coefficient take square called coefficient of determination. Is a measure of the variation of the dependent variable y. Y is dependent variable that is explained by regression line, and the independent variable is x. Since R squared is positive, so the R squared is greater than or equal 0, less than equal 1. If R squared equals 0, then the least square regression line or best fitting line cannot explain any of the variations. If R squared equals 1, then the least square regression line. Least square regression line just is a linear regression line. Least square regression line is a linear regression line, just like we find out before y hat, which y hat equal b0 plus b1x is linear regression line. It's also called least square regression line. Explains 100% of the variation in the dependent variable. Question 11. Use the correlation coefficient R found in question 4. We found R in question 4 is negative 0.944. To find the coefficient of determination, which is R squared, and the coefficient of non-determination, which is 1 minus R squared, and interpret the meaning of each. Coefficient of correlation coefficient found in question 4, R is equal negative 0.944. Then the coefficient of determination is R squared. So R is negative 0.944 squared. You got 0.891. So we say about 89.1% of the variation in the final grades can be explained by the linear relationship between the number of absence and the final grades. The B, find the coefficient of non-determination. Coefficient of non-determination formula is 1 minus R squared equal 1 minus R is negative 0.944. Plug it in and square it, and you will get is 0.109. So this means about 10.9% of the variations of the final grades cannot be explained by the variation of the absence. Question 12. A correlation coefficient R was calculated to be if R is 0.830. The coefficient of non-determination would be 0.170, true or false. Coefficient of non-determination is 1 minus R squared. So in this case is 1 minus 0.83 squared. And if you figure out this, it's not 0.17. You cannot just do 1 minus R. 1 minus R is equal 0.17. That's not right. You have to square it. 0.83 squared and 1 minus it. So this is a false. Next question. We call standard error of the estimate. The formula E estimate equal to square root of unexplained variations over degree of freedom n minus 2. Unexplained variation is observed y, value y, minus y hat square. Explained variation is